Hello, in this video, I will explain to you on how to solve this problem. Let's read the problem first. Arlene is to walk across a high wire strung horizontally between two buildings 10 meters apart. The sag in the rope when she is at the midpoint is 10 degrees, as shown in figure 439. If her mass is 50 kilograms, what is the tension in the rope at this point? Okay, let's draw the forces that work on this rope here and use this here, the midpoint of the rope, as our reference point here. And the most obvious force that is worked on this is the weight of Arlene, right? So she pushed the rope down like this by her weight. So I will have this is the force by her weight, Fw. But then Fw is equal to the mass times gravity. Good. And then the tension of the rope here, we have two, right? So one on the right, let's name this T, and also one to the left. Because they are in the midpoint, they will be the same. So we will have T here, T, and we can project both of T here into X and Y axis, right? So we will have this one here as Tx, like this. So we'll have T in the X direction, and there we also have T also in the X direction. Okay, but because they are the same force in the opposite direction, they will cancel each other. What we need to care about is the vertical one. So I will have this one here, one of them projected from here. So I will have Ty here. And also from this one here, which is also Ty. So we have 2 Ty here that is on the positive vertical direction, right? So let's do analysis, but then we are looking on the vertical direction because in the horizontal direction, they cancel each other. So we don't need to do analysis on the horizontal direction. So we will need to do the Newton's second law here. Sigma F is equal to mass times acceleration. But we need to do it in the y-axis. So we'll have AY, and this is also Fy. But then on the right-hand side here, we will have the acceleration is equal to 0. Why? Because the system is not moving, especially in the vertical direction here. Good. And then on the positive direction, we have these two forces, right? Ty and Ty. So I'll have Ty plus Ty. And then on the negative direction, I will have Fw. So I'll have minus Fw. And that will equal to 0. Good. And then we need to find out what is T, right? Not Ty. So how to do that? Remember that Ty is the projection of T into y-axis. But then this is theta, right? So we will have theta is this angle here. But then this is also this angle here. So the horizontal projection here, Tx, is equal to T cosine of theta. Why? Because this is the adjacent and this is the hypotenuse. Adjacent and hypotenuse is cosine. But then Ty is obviously T sine theta, right? So if we put this vector here, it will be the opposite side of the angle, and T is the hypotenuse. Opposite and hypotenuse is sine. So we only care about Ty here. So let's plug that in. We will have T sine theta. So we'll have T sine theta. And then this one here also T sine theta. Good. And then minus Fw, that will be mass times gravity. So we have mg, and that will equal to 0. This is the same one. So I will have 2T sine theta. That will equal to mg. And we can divide both sides by 2 sine theta, right? So we will have T is equal to mg divided by 2 sine of theta. Now we have all the values, right? So we will have the mass of Arlene, the gravitational acceleration, and also the angle of the rope. And that will be T is equal to the mass 50, and then times gravity, we will have 9.8, and then divided by 2, and then multiplied by sine of 10 degrees. So I'll have 10 degrees here, and nothing that we can do except punch this into calculator. Let's do that. So we will have this number here, 50 times 9.8 divided by 2 multiplied by sine of 10 degrees. We already have in degrees here, so we will have the result here. That will be 1411. Okay, I think 1411, and the unit here will be in Newton. So that is the tension of the rope when Arlene is in the midpoint. So this is the answer here. And I think that's all for this problem. The answer is 1411 Newton. Okay, and as usual, thank you for watching. If you get any question, send me your problem here. My name is spelled pronunciate RD Satriawan1@gmail.com. So my name is RD Satriawan, and you can add 1 and at gmail.com to send me an email. If your problem is interesting, I will make a video about that. Okay, thank you for watching and see you in the next video. Bye bye.